As naval procurement enters a highly unstable era of global competition, Europe's two premier maritime powers have taken fundamentally opposite paths to project strength at sea. On one side stands France's with its conceptual Porte-Avions de Nouvelle Génération, or PANG, a massive 75,000-ton supercarrier designed with nuclear propulsion and electromagnetic catapults. On the other side stands the United Kingdom's active Queen Elizabeth class, a 65,000-ton carrier optimized for conventional integrated electric propulsion and short takeoff vertical landing aircraft. This is not a simple choice of ship design. It is a profound divergence in national industrial philosophy that dictates how European power will be organized over the next 50 years. The primary argument for France's PANG lies in the absolute operational freedom offered by its dual K-22 nuclear reactors. These reactors deliver roughly 440 megawatts of thermal energy, about 50% more thermal power than the current Charles de Gaulle, providing unlimited propulsion range while simultaneously supplying enough instantaneous energy to power 3 EMALS catapults. This is a high energy load that the British gas turbines and diesel generators cannot match without severely sacrificing the ship's primary propulsion speed. In a prolonged conflict, the French carrier can maintain its combat station indefinitely, while the British platform remains chained to a complex logistics train of fleet tankers, creating vulnerability windows during at-sea replenishment. However, France's obsession with nuclear strategic autonomy introduces a severe operational paradox that the British deliberately avoided. Because the PANG carries a staggering price tag of over 10 billion euros, France can only afford to build a single hull, meaning history is simply repeating the structural flaw of the current Charles de Gaulle. Nuclear-powered carriers require extensive, multi-year dry dock overhauls for reactor refueling and deep maintenance, during which France will possess zero carrier capability. By building 2 conventional carriers, the HMS Queen Elizabeth and HMS Prince of Wales, the Royal Navy ensures that at least one deck is consistently available for global deployment, trading nuclear endurance for reliable operational availability. The tactical divide becomes even more acute when examining how both platforms launch their respective air wings into combat. The French PANG utilizes the American-designed Electromagnetic Aircraft Launch System, or EMALS, purchased directly from General Atomics to fling heavy, fully loaded fighters into the sky. Conversely, the British class relies on a mechanical ski jump utilizing short takeoff and vertical landing, or STOVL mechanics, for the F-35B. While the ski jump eliminates the high mechanical complexity of complex catapult systems on the flight deck, it forces a devastating tactical compromise on the aircraft themselves, severely limiting their maximum takeoff weight.
A closer look at the operational data reveals that the true advantage of EMALS is not the number of flights, but the payload per flight. The Queen Elizabeth class is designed for high-tempo operations with a short-term surge capability exceeding 100 sorties per day, showing that STOVL operations allow for quick deck cycles. However, those F-35Bs must sacrifice internal fuel or weapons to safely clear the ski jump. The French PANG allows its future fighters to launch at maximum certified takeoff weight, allowing for significantly greater fuel and ordnance loads. Furthermore, EMALS allows France to operate the fixed-wing E-2D Hawkeye, whose radar horizon from 30,000 feet extends roughly 100 nautical miles beyond the British helicopter-based equivalents. Despite its technical superiority in the air, the physical construction of France's PANG exposes a complicated logistical handoff under current industrial constraints. The massive hull will be built at the civilian Chantier de l'Atlantique shipyard in Saint-Nazaire, as it is the only dry dock in France large enough for a vessel of that scale. However, because Saint-Nazaire is a civilian facility, it completely lacks the military infrastructure to handle radioactive materials. Consequently, once the partially fitted hull is completed, it must be towed roughly 1,500 kilometers around the Iberian Peninsula to the military port of Toulon just for the installation and fueling of its nuclear reactors, an unprecedented civilian-to-military handoff. Operating a nuclear supercarrier also inflicts a massive hidden financial tax on a nation's defense budget that conventional ships completely avoid. Beyond the initial multi-billion-dollar construction cost, the specialized workforce, safety enclosures, and strict regulatory oversight required to maintain the K-22 nuclear reactors drain vital naval funding year after year. The British Queen Elizabeth class, while less prestigious, utilizes commercial off-the-shelf marine engineering that can be serviced in standard naval dry docks with far less specialized equipment. This allows the Royal Navy to distribute its funding across a broader fleet of escort frigates and destroyers, rather than concentrating its entire fiscal energy on a single nuclear asset. Ultimately, the comparison reveals a fascinating swap of national dependencies. Critics point out that by purchasing EMALS from Washington, France failed to achieve true independence. However, the reality is that France willingly sacrificed 100% autonomy in its catapult system, specifically to protect its sovereignty in nuclear propulsion and domestic fighter design. The British did the exact opposite. They avoided dependency on American catapults by choosing a conventional ski jump, but accepted total dependency on American F-35B stealth software and logistics from day one. Both nations compromised on autonomy, but France chose to protect its sovereign power source, while the UK chose to protect fleet mass.
In the final analysis, comparing the French Pang to the British Queen Elizabeth class reveals a fundamental clash between maximum capability and practical mass. The French system offers the ultimate expression of naval perfectionism, delivering a nuclear-powered hull with unrestricted aircraft payloads at the cost of catastrophic single-ship vulnerability. The British system delivers a highly capable, redundant, and fiscally manageable two-ship fleet that keeps a flight deck at sea even when one is undergoing deep maintenance. As Europe prepares to face a dangerous and contested maritime future, the nation that truly dominates the sea will not be the one with the most sophisticated blueprint, but the one that can actually keep its carriers deployed when the crisis begins.